Hi class, for this first video we're going to talk about multiplying radicals, dividing radicals, and adding and subtracting radicals. When I multiply radicals, the first rule that I want to know is that it turns out I can take this radical sign. Well, hold on, let's just do a quick review over here for the sake of vocabulary. This thing right here, this is called a radical. And then all the gobbledygook inside, let's say we've got 27 x to the fourth y squared. This stuff inside here is called the radicand. And then if there is nothing written here, which is also this spot right here is known as the index. If there's nothing written here, it's actually implied that there is the square root. In other words, you're looking for pairs of 2. However, it's possible that things could be written there, and then, like if there's a cubed root, you'd be looking for chunks of 3. And so in this case, say we're working on this specific problem right here, I could break down this 27 into 3 times 9, and well, 3 times 9 actually ends up being 3 times 3 times 3. And since I'm looking for chunks of 3 right there, I would write that 3 outside the radical, and then I'm looking for chunks of 3 here, which is what that x is, x times x times x times x. So here's my chunk of 3. So there's an x on the outside, and then one x stays in the radicand, and a y squared. This ends up being third root, so 3x third root of xy squared. Okay, so let's go back to multiplying radicals and dividing radicals. The general term says that if I have square root of x times the square root of y, it means that I can rewrite it as the square root of xy. And then when I'm dividing radicals, well, what that means is if I have the square root of x divided by the square root of y, I can rewrite this as the square root of x over y. Alright, so let's grab a different color here, and then let's work in black, and then do a quick example. So for example here, say I'm working with the square root of, I don't know, 3 times the square root of 3. Well, I can rewrite that as the square root of 3 times 3, which equals the square root of 9, and the square root of 9 equals 3. Okay, now notice that right in here there wasn't anything written there, so we were talking about the square root. Let's work one where we have a cubed root. So let's say we have a cubed root, so there's my little 3 there, cubed root of 4 times cubed root of 16. Well, 4 times 16, that's going to give me 4, carry the 1, it's going to give me 64. And I can rewrite this as the cubed root of 64. When I break down 64, as it turns out, I get 4 times 4 times 4. Since I'm looking for a chunk of 3, because this index tells me I'm looking for a chunk of 3, the answer is just 4. Okay, when I'm dividing radicals, it's the same deal. Say I have the square root of 8 divided by the square root of 2. I can rewrite this as the square root of 8 over 2. And 8 divided by 2 equals 4. So what we're looking for actually is the square root of 4, and that just equals plus or minus 2. We're not really going to worry about that plus or minus part, mainly just 2. Okay, when I add and subtract radicals, it's just the same thing as if I was trying to say add 3x squared plus 2x squared plus 4x plus 1. These coefficients I can totally add, but I can only add them if they have like terms. In other words, I couldn't add this 4x with the x squareds, and nor could I add the 1 with the 4x. The matching thing, instead of using these x squareds, the thing that is matching is the radicand. All right, what that means is if I have, say, 3 plus square root of 15 plus 2 root 15 minus, I don't know, 3 root 2. Well, because the radicands are not matching for this statement and this statement right here, I can't add them or subtract them together. But what I can do is these two are the same, the radicands are matching, and then as a result what I can say is, well, 3 plus 2, that just gives me 5 root 15 minus 3 root 2. And there's your simplified answer.